Molecular photonics, the science of light and molecules. Molecular photonics, the science of light and molecules. The study of molecular photonics lies at the intersection of chemistry and physics, focused on the interaction between light and molecules. The field has advanced rapidly over the past few decades. The discovery of new materials and techniques that allow for the manipulation of light at the molecular level. Molecular photonics is a fascinating area of research that has the potential to revolutionize a wide range of industries, from energy and medicine to electronics and computing. At its core, molecular photonics is concerned with understanding how molecules interact with light. This includes both the absorption and emission of light, as well as the response of molecules to external fields, such as electric or magnetic fields. By understanding the behavior of molecules in the presence of light, researchers can design new materials with specific optical properties and develop new applications for existing materials. One of the key areas of focus in molecular photonics is the development of new light sources. These sources include lasers, LEDs, and other devices that emit light of a specific wavelength and intensity. The development of these light sources has enabled advances in fields such as telecommunications, where fiber optic cables are used to transmit information at high speeds over long distances. Another area of research in molecular photonics is the development of new materials for use in solar cells. These materials are designed to absorb specific wavelengths of light and convert that energy into electrical energy, which can then be used to power homes and businesses. The development of high-efficiency solar cells is critical to the future of renewable energy, and molecular photonics is helping to pave the way for these advances. In addition to energy applications, molecular photonics is also being used in the field of medicine. Researchers are developing new medical imaging technologies that use light to visualize the structure and function of cells and tissues. These technologies have the potential to revolutionize medical diagnosis and treatment, allowing doctors to detect diseases at an earlier stage and develop more effective treatments. Molecular photonics is also having an impact on the field of electronics. Researchers are developing new materials that can be used to create smaller and more efficient electronic devices. These materials include organic molecules and polymers, which have unique optical and electronic properties. By incorporating these materials into electronic devices, researchers hope to create new technology with improved performance and reduced power consumption. One of the most exciting areas of research in molecular photonics is the development of quantum computing. Quantum computing is a new paradigm in computing that utilizes the principles of quantum mechanics to perform complex calculations. Molecular photonics is playing a critical role in the development of quantum computing by providing the tools and techniques necessary to manipulate and control quantum systems. Despite the many potential applications of molecular photonics, there are still many challenges that need to be overcome before these new technologies become practical. One of the biggest challenges is the development of new materials that can be produced at scale and at a low cost. Many of the materials used in molecular photonics are highly specialized and difficult to produce, which makes them expensive and limits their widespread use. Another challenge in molecular photonics is the development of new techniques for controlling molecular interactions with light. These interactions can be complex and difficult to predict, which make it challenging to design new materials with specific optical properties. Researchers are developing new computational tools and experimental techniques to address these challenges, but there is still much work to be done in this area. Finally, there is a need for greater collaboration between researchers in different fields, including chemistry, physics, materials science, and engineering. The field of molecular photonics is highly interdisciplinary, and progress will require experts from different fields to work together to solve complex problems. Moreover, the exploration of molecular photonics has the potential to shed light on fundamental questions about the nature of matter and the universe. It has already led to the discovery of new phenomena, such as photon inversion, where two or more low-energy photons are combined to form a higher-energy photon. This has important implications for energy conversion and could lead to the development of more efficient solar cells. Molecular photonics is also revealing the complex interactions between light and matter, such as the quantum states of molecules and the role of molecular vibrations in absorption and emission. These interactions are not fully understood and are the subject of ongoing research in the field. By studying the fundamental physics of light and matter, researchers are gaining insights into the nature of the universe and laying the groundwork for future discoveries. In addition to advancing scientific knowledge, molecular photonics is also contributing to the development of new technologies for environmental sustainability. For example, researchers are working on developing new materials for carbon capture, which involves capturing carbon dioxide emissions from power plants and other industrial sources. The materials being developed use molecular photonics principles to selectively capture carbon dioxide and release it upon exposure to light. This technology could potentially reduce greenhouse gas emissions and combat climate change. Another area where molecular photonics is being applied is in the field of sensing and detection. Researchers are developing new sensing technologies that use light to detect and quantify various substances in the environment. For example, light-based sensors can be used to detect pollutants in the air or water, or to monitor the levels of drugs in a patient's bloodstream. These sensors have the